lot of people are unclear about terms like EDA, CAD for LSI, VLSIs. Can each of the panelists, starting with Professor Patil, give us his definition of the subject area and, in fact, the core components that constitute EDA and CAD tools?
Well, EDA, tools really refer to, at least in my mind, to the design and verification tools that engineers need in order to design these complex chips. As they say, when you do the tape out, the die is cast. In today's term, just the mass set, it would cost you more than $1 million. So you have to be very, very accurate. Firstly, you have to do the design, then be very accurate. And the tools, which essentially are software tools, that are necessary to navigate through the process, deal with the complexity, get the job done in timely manner, and reduce the risk of it not working. That whole setup, is, into my mind, the EDA. Of course, here it applies to the world of chips. But there is similar thing for other kind of, including buildings and doing planes and so on. But that's not what we're talking about.
Okay, how about Doug? Your perspective, please.
Yeah, so I think the terms have evolved over the years. In the early days, I'm talking about 60s and 70s, there wasn't any of the front-end tools, or very few of the front-end tools that Suhas was just referring to. And when people talked about design automation, they typically used the word CAD, computer-aided design, and it typically referred to physical design, which were some primitive tools in the physical layout or placement and routing and that sort of thing. Starting in 1980-81, there became a whole industry around the design creation part of the problem. DAISY, started with DAISY, Mentor, Valid. Later on, Synopsys, Cadence became the dominant players. And that industry overall adopted the term EDA, or electronic design automation, and in fact became a real industry with the formation of the Electronic Design Automation Consortium, which includes a whole family of tools. Now you have tools that not only help you do design, but help you measure the heat that's being generated by that design and measure the tremendous, all the timing issues and all the other complications that come from very advanced manufacturing processes. So we started out with a very simple set of tools, computer-aided design, doing physical design, but it has evolved into an extremely complex network of tools that do a huge variety of things, from top-level system idealization and verification down to physical verification and timing verification and other complexities. I think the overarching term continues to be EDA, but there's a lot of variations of design automation below that.